The estimate at complete for time uses historical schedule performance to estimate project duration. The estimate can be used to assess the feasibility of plan duration. Further, the estimate can be placed within a variance, a range of likely values. To calculate the estimate, we need base data. Get the plan value. Here it starts at $15, then goes to $35, $73, $120, $190, $260, $320, $375, $435, and finally $525. Get the earn value. In this case, it starts at 0 and then climbs to $25, $65, $110, $175, and then $245 at period 6. We'll stop there so that we can see what the estimate does for us partway through a project. Calculate the earn schedule. Because the earn value started at 0, the earn schedule starts at 0 and then goes to 1.5, 2.79, 3.79, 4.79, and 5.79. Calculate the schedule performance index for time. The SPIT goes from 0 to 0.75 to 0.93, 0.95, 0.96, and again 0.96. Now we can calculate the estimate at complete for time. To start, we have to choose the best formula for the estimate. Here are the selection rules. First, look at the values for the schedule performance index for time. Is there some separation between the values and the nominal value of 1.0? Yes. Is the divergence in values across periods not large? In this case, the answer is no. The values start at 0 and climb well above 0.90. In this case, the divergence is large. Therefore, use the new formula for the estimate at complete for time. In that formula, AT is the actual time, PD is the plan duration, you're already familiar with ES as the earned schedule, and finally there's PF, which is a performance factor. So what the formula is telling us is that we take the actual time and then we find the difference between the plan duration and the earned schedule. We divide that by a performance factor and we add that back to the actual time, and then that will give us the estimate at complete for time. That performance factor could be something like the schedule performance index for time, but testing shows that a performance factor equal to 1 gives the best results. So the formula simply becomes the actual time plus the planned duration minus the earned schedule. That gives us for the first period 1 plus 10 minus 0 for a total of 11. And in the second period that gives us 2 plus 10 minus 1.5 for a total of 10.5. In the third period then it's 3 plus 10 minus 2.79 for a total of 10.21. And the 10.21 is then repeated for periods 4, 5, and 6. Next, let's graph the measurements. On a simple XY grid, let's use the vertical axis for values of the estimate, and we'll use the horizontal axis for the elapsed periods. In this case, they would run from 1 to 12, although we only use the first 10. Next, set the scale. The maximum is either the estimate or the planned duration, whichever is greater. Now in this case the estimate is 11 and the planned duration is 10, so the maximum is 11 and the scale looks like this from 1 through 11. Plot the observed values for the estimate. They start at 11 and then go to 10.5 and then 10.21 for the next 4 periods. Connect the dots. How do we interpret the graph? We set a benchmark for comparison. Use the planned duration. It's a straight line at 10 periods. From the benchmark, set threshold values. They come from governance documents, project plans, or contracts. For the estimate, common thresholds are 10% above and below planned duration. Given that the planned duration is 10, the upper threshold is 11, and the lower threshold is 9. Note that the current estimate does not breach a threshold. That suggests that it's not time to take action. But let's ask, is there a trend? Yes, there are at least 3 consecutive periods in which the estimate is headed in the same direction. But the trend is not approaching a threshold, so it's not yet time to act. Hold on, there's one more thing to consider. The estimate at complete for time uses current performance to estimate future duration. But what about historical performance in earlier periods? And what about the impact of risks and external factors? The estimate at complete for time is only one of a range of likely values, and it might be that there's a breach by one of those other values. A separate video describes how to set up and use the variance. Still, when deciding on action, keep the range of likely values in mind. For now, let's sum up the new estimate at complete for time. It estimates duration based on current schedule performance. It applies when the schedule performance index for time either stays close to the nominal value of 1.0 or diverges a lot over time. It's not in the middle ground between those two extremes. A threshold breach calls for action because planned duration is at risk. In the absence of a breach, the variance of likely values comes into play. For more information on this and other topics related to earned schedule, here are some references.